Hello here. Today I talk about design of industrial truss. Now start design of an industrial truss. This is an industrial truss supported on pin, one side hinge and another side pin. These are the purlin of the truss member. This purlin is channel section and these are the ridge of the truss. This is the roofing system and U1, U2, U3, U4, U5 these are the joints. Similarly L0, L1, L2, L3, L5, L4, L6 is the joints. Height of the truss 24 feet. This is the big truss and each span of this truss is 20 feet and which consists of 6 span. That means total span length of the truss 120 feet. Now plan of this starts. This truss is this is the truss. This is the plan of the truss and this is the another directions. These columns are concrete column and span length is so much than use truss frame. Truss frame is suitable for long span. In roofing system, inclined top chord, this chord sometimes called cross chord, inclined top chord are provided and these are the sagged with the inclination and these are the purlin at top, bottom and chord bracing at bottom. This is the building plan. Now calculations. Total span of the truss 6 at the rate of 20 feet, that means 120 feet. Total height of the truss 20 feet, spacing 30 feet. These are the spacing. These are 30 feet and these are 30 feet. Piece angle alpha. Now piece angle alpha equal to 10 inverse 24 divided by 60. These are the 60 means this portion is 60. These are the 24. Tan alpha equal to perpendicular divided by base and get this value. Now dead load roofing 2 PSF assume purlin 1.2 1.5. Normally roof we are using profile sheet. Weight of profile sheet per square feet is 2 pound is the assumptions. That means something like as 2 kg, 1 kg and sagged plus bracing equal to 1 psf. Basic wind speed V equal to 120 mile per hour. Material property compressive strength of concrete like as concrete column A prime C equal to 3 ksi and Fy equal to 4 ksi. Now at first of all design of purlins and sagged. Which are purlins and sagged? These are the purlins and these are the sagged, and in this case these are the sagged and these are the purlins. These are the purlins. These are the purlins C channels. And now purlin length equal to spacing of truss 30 feet. These are the purlin and these are the spacing of truss. This is 30 feet. And 2 purlin, 2 span presents in here, 2 symmetrical span presents in here. Now GI sheet roofing 2 PSF, self weight of purlin 1.5 PSF and total load 3.5 PSF. Purlin spacing SP equal to length of top chord U1, U2, length of top chord, which is top chord U1, U2. These are the length of top chord. Length of the any one of the segment considered for design. Top chord U1 U2 equal to root over 20 square plus 24 divided by 3 square 21.54, and finally UDL, uniformly distributed load on Purlin, 3.5 into SP. Why 3.5? These are the total loads. Sheet roofing plus Purlin load 3.5 PSF into SP, pound per feet. And now WDLX equal to WDL sin alpha. Because of this are the inclination of load. These loads is come from this base from, and this is 28 pound per feet. And for Y, UDL Y, UDL equal to cos alpha. And now wind load, calculations of wind load. Basic wind speed V equal to 120 mile per hour. Basic wind pressure Q equal to just this is the formula, and keep the formula, and this is the result. And wind pressure for wind surface equal to Q equal to minus 0.7 Q for alpha. This is the condition, and this condition, this is the equation, and another condition is that, and other condition is that. And now wind pressure for leeward surface is for any fellow of alpha, then this angle is the wind pressure for windward surface PWW, and wind pressure for leeward surface PW. This just input this value and get this value. And windward load, uniformly distributed load on windward surface WW equal to 21.2 into SP. Previously gets this value as speeds, and leeward surface this are the value, and this are the Purlin, this are the dead load. These are the local axis of Purlin, and UDL, UDL X, UDL Y, and this is the angle of Purlin. Windward wind load, this windward wind load this direction, and leeward wind load this direction. Now load combination and biaxial bending. It is clear from the preceding analysis that leeward side is more critical for wind loading. Therefore, the combination of dead load and leeward wind load provides the governing design conditions for Purlin, and combined uniform distributed load in y direction Wy equal to for this value, and combined the uniform distributed dead load in x direction at the span of Purlin 30 feet, already known. Span of Purlin 30 feet, it is simple supported in y direction. Now then the moment W is square divided by 8, and it is the mid span moment kick per feet feet square due to sag or 2 span continuous in the x direction. This value. And now design of Purlin, the absolute maximum potential compressive due to biaxial bending is that we know the biaxial bending. This is the moment, this is the section modulus of two direction moment, just addition. And finally moment about Sx, so about the modulo about the x and y axis. Level bending stress equal to we know in design of steel, level bending stress equal to 0.66 Fy. Now calculation of optimum Purlin section. These are the value of Purlin section. Okay, this is the section of Purlin, and now calculate self weight of Purlin. Now design of sag rod, same procedure follow for design of sag rod. These are the this. Now calculation of point dead load and wind load truss analysis. In this section, the uniformly distributed load from the roof as well as from the wind are concentrated on the truss joint of subsequent analysis. Now calculation of point load, total roof load including roofing, Purlin, sag and bracing at the PSF, Purlin spacing at the feet, truss spacing at the feet, concentrated roof loads on truss joints at the keeps, assumed this self weight of truss at the keep and horizontal span to be divided among to the top and bottom chords, and then concentrated self weight on the joint truss at the dead load on top truss at the bottom truss at the and wind at the. Now just input this value top and bottom, and finally member truss force reaction due to dead load. Finally input this value and calculate the member force in this process, similar process. Now input the design pressure, wind pressure upward and leeward pressure, and input this value in the wind direction, and the member force should be calculated in windward direction. These are the leeward directions. And now load combination and design of truss member. The member force and support reaction calculated earlier for point dead loads and wind loads are combined in this section to obtain the design member force and support reaction. And combined of dead load and wind load, the calculation for design force is best carried out In tabular form shown in below, these are the tabular form: bottom chord members, top chord members, vertical members, diagonal members. These are the all force member name. Member force keeps dead load, wind load, in windward direction, then leeward direction, design force tension and compression and keep. And now design concept of truss member. These are the design concepts, equation, loves and slenderness ratio. These are the slenderness ratio, checking this ratio, and these are the section rulers. And now design of bottom chord members. These are the bottom chord members: L0, L1, L5, L6. Maximum tension force 30.69 kips and maximum compression at 60.24 kips. Table of bottom chord design chart of chord member, top chord design chart, design of vertical diagonal. This is the long, this is the big example. But very interesting and very easy. And wave design chart. These are the wave design chart. This is the wave member. Design of bracing and connections. If we provide truss, connection and bracing are required. So design of bracing and connection. These are the three-dimensional view. These are the bracing, vertical bracings. Bracing. These are the another types of bracing. And these are the bottom chord or try. Design of bracing, connection, bracing, design force action equal. And this is the joint, gusset plate. This is the welding joint, also weld. These are the welding portion. Another welding joint is the connection of roof system. This is the plates, connection plate. Design of anchorage and support. Support and anchorage design is the same procedures. And the hinge of support L1. This is the support. This is the anchorage. This is the RCC column, concrete pedestal, and stay on the truss. And this is the anchorage, anchor poles, and this is the anchor support. Okay, thank you very much for watching my video, and please subscribe my channel if you interested my video, and click bell icon for any updates video. Thank you.